Hey guys, it's ZS, and I want to give you guys an intro to limits. Now, limits you might have seen a lot, which is just expressed as lim as x approaches some number of f of x equals that function at a. Now, you'd ask yourself, why would anyone use this? Now, the reason is because as let's say, for example, I don't know, 1 over x squared. Now that graph looks like this. It approaches to infinity. Now, some person might be like, well, what is 1 over x squared when x is 0? Now, x can't be 0 here, obviously, because 0 can't be in the denominator, because once you get something like this, it's undefined. Right? Now, you don't have that problem with limits, because limits basically don't let x equal 0. So we're going to give you your first limit problem, which is limit as x goes to 0 of 1 over x squared. Now, what you're going to do is you're going to draw a graph, and you're going to see where that graph leads to. Now, what you're going to do is you're going to say, what if x equals negative 1? What if x equals 1? What would those values be? And then you might be like, well, what if x is, 0.1? What if negative 0.1? What if x is 0.1? Right? And we're going to evaluate, well, these are the three things to evaluate a limit. Now, a limit has to be continuous. So if it's like, I don't know, a line, and there's like a circle here, and then it continues on at like 3, and you do the limit as x goes to 3, it's not gonna give you an actual answer. Now, you can evaluate it. I'm getting ahead of myself. There are 3 ways to evaluate a limit like this, but first we're going to solve this problem. Now, if you plug, actually, I'm just gonna tell you the 3 ways. Now, the first way is finding the limit from the negative direction, which basically just means to the left of the number. So if I brought up that graph again, where like, x is 3 here, you can evaluate the limit as x goes to 3 of whatever function this is. I guess it would be like, I don't even know. But regardless, whatever it is, it's going to be the y. The y is always f of x. Think of f of x as y. Always think of f of x as y. Now, this number we'll say is like 1, and we'll say this number is 2, and this number down here is 1. So the limit is 3. As x approaches 3 is 2, because it's only empty at this point, 3. So it would be 2. So you need to know what this is, right? It equals some number, so I'm going to put n, to the limit as x goes to some number. You know what? We're going to use a for any of them. Some number from the right. The right side is the positive side, so from this side, which here, limit as x goes to 3 from the positive direction. Here is 1. Now, this means, like, if I get, like, I don't know, 3.1, it's going to be, like, this 1 over here. And if I get, like, 2.9, it's going to be this point over here. Right? So, this from the right direction is going to equal 1, right? So, it also has to equal some number. But if, they just have to equal some number, which is why I'm going to put a subscript of 1 here and a subscript of 2 here. Now, the important part is, the first number has to equal the second number. So in this case, this doesn't have a limit, undefined, or does not exist, actually. That's what people do for limits, does not exist. Now, it doesn't exist if they don't converge to the same point. If they don't meet together at that same point, then it isn't a limit, or it is in a limit that does not exist. Now, we're going to get back to this problem. So, if we evaluate the limit as x goes to 0 from the negative direction of 1 over x squared, let's say x here is like, I don't know, negative 0.001. Well, basically, we're just saying that x is a really, really small number, right? Because something that's really close to 0 just means it's a really, really, really small number. Now, if 1 over, let's say, 1 equals 1, then we know 1 over 0.1 equals 10, right? Now, 1 over 0.01 would equal 100. So as we know, as this number at the bottom shrinks, the number that comes out gets bigger. So if 1 was over a really small number, it would equal a really big number. Now, this really small number is infinitely close to 0, but it's not 0. It's infinitely close to 0, which means that it would be it would be a really small number, and that really small number squared would just be an even smaller number, or whatever it is. But regardless, this number, since it's 1 over a really, really small number, it's going to approach infinity. Because when it gets so close to 0, when it gets really, really, really close to 0, it's going to be a really, 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 really big number. Now, there's no way to get really close to 0 but not be 0. But we know that if it's a really, really, really small number, it's going to get really, 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 really big. So we can say that it is infinity as it approaches 0 from the left side. I mean, if you look at the graph here, it looks like it's approaching infinity, right? Especially from the left side. Now, we're going to do the same thing for the right side. Now, you're going to say, but it's a negative, it's squared, so it's going to go up like that. Now, if you have the limit as x goes to positive 0 here, you can just plug in a really, really small number into x and then square it, and then you get infinity as well. So the left and the right are giving us both infinity. So this limit of 1 over x squared is infinity. Now, if you have a limit, this is a rule of thumb. If there's a limit of sine of x over x, that just equals 1. There's a mathematical reason for that. Just know that whenever you see it. So we're going to use a trig one, because I love trig. Gotta love trig. You gotta love trig. Now, if I do the limit as of cosine 2x over x as x approaches 0, now we can't just plug in the number like any normal limit, because of the fact that x is at the bottom here and x can't equal 0. Now, cosine 2x is a trig identity, and the trig identities can be turned, for cosine 2x specifically, it can be turned into cosine squared x minus sine squared x, and we're just going to put that in here. So it's going to turn into the limit as x goes to 0 of cosine squared x minus sine squared x over x, right? And now what we're going to do is we're going to try to separate these two, because we know that the limit as x goes to some number sine x over x equals 1. If we know that, then we just need to separate these two into cosine squared x over x minus sine squared x over x. Now, I want you to remember, this is the additive property of limits. The limit of x going to 0 of let's say two functions, is the same as the limit as x goes to 0 of f of x plus the limit as x goes to 0 of that other function as well. So you can break up the limit like that. So if we find the limit of this, then we can just leave that alone and add it on to whatever the limit of this is. So sine squared of x over x is just sine over x times sine over x. Sine over x times sine x, which is just here, it would just be sine x over x times sine x, and if we know that x equals 0 here, this just turns into 1, and then it's times sine x, so when x is 0 for sine, which is over here, for people who do trig, you know where that is, then, no, you're right, wait. When x is 0, sine is up here, because it's the unit circle travels around like that, so as x is 0, the function gets up here. So sine of x is just 1 here. It could technically be -1, but we're going to stick with 1 here. 1, right? So it's just 1 times 1, which is just 1. Now we just have to worry about 1. Oh, this is a minus, so we're just going to say -1 times the limit as x goes to 0 of cosine squared x over x. Now what we're going to do to solve this problem is we are going to multiply by x on both sides? Maybe? Oh, actually, if we don't really know the answer here, we can just approximate it from the left and from the right. So as the limit of x goes to 0 of from the left side, let's say, of cosine squared x over x. So as x is some really small number, this is going to approach some really big number. So if cosine squared x of 0, so where x is 0, it's going to be right here. No. When x is 0, cosine of x is going to be up here, right? Because this is when x is 0. So then, that would mean that cosine x here would be 0. And it would be 0 over some really big number, but it doesn't matter what the number is because it's just going to be 0. Right? Now, if you do it from, so that means that as x is getting smaller, it's always going to be 0 over here. So it's probably going to be, so f of x would end up somewhere here. This is where it would go. And then you evaluate it from the right, and from the right would give you the same answer here, where this would be some really small number, and it would be 0 over that really small number, which would just be 0. So it would be -1 times this limit, which is just 0. And so the limit as x goes to 0 of cosine to x over x would just be 0. Thank you, guys.